This example is very similar to the one that we just did, except now we've got a strap. So a certain strap on a suitcase will break if the tension exceeds, let's make this something I can draw with. So the tension can't exceed 10 kilogram WT. Okay, calculate the greatest acceleration. So what is the acceleration? With a 12 kilogram suitcase that can be dragged up a smooth plane at an inclined angle of 40 degrees to the horizontal when the strap is inclined at 20 degrees. Okay, so pause the video, see if you can have a go at drawing this. So now I've got my inclined plane. Whee! Here is my suitcase that weighs big old 12 kg. Now it's got a downwards force of 12g. It's got a normal force acting up in this direction. Then instead of having a force going this way, we've got a strap that's going up this way and we can't let it exceed 10. So 10 is the thing that we're looking for here. Now kilograms WT is the thing we use for newtons, so we want it to be 10 newtons. Now in here, this angle is 20 degrees. This angle down here is 40 degrees. So this gives me everything that I need to know to be able to start resolving these. Now, first thing we're going to do is we're going to look at the ones in this direction. So this way, and then this one would go that way. Our other forces would be that one and that one. Okay, so if we're looking at it being, which way is acceleration? Positive. Calculate the greatest acceleration dragged up. So we want the acceleration to be going up the plane. Okay, so we know that force equals mass by acceleration. We know that our mass is 12 kilograms. Our acceleration is the thing that we're not sure of, and we want to work out our force. So because we're acting up the plane, it means we're looking at this component and this component. So next thing we're going to do, in here, this one there, that's 40 degrees, meaning that this one is sine. So in the negative direction, minus sine, that has a 12, let me start that again. It's traveling in the negative direction. 12g is this line, which means that that's the hypotenuse. It's going to be sine because it's opposite to the 40 degrees. And then in this direction, we're adding it because it's going the same way as the acceleration. We've got 20 degrees, and that's our angle. That's the right angle, meaning that this one is cos, and it's got a force of 10 newtons. So now all I have to do, punch this in the calculator, divide it by 12, and that's going to leave me with my acceleration. So 12 times 9.8, or negative, sine of 40 degrees plus 10 cos 20 equals, and then divide it by 12. Now I've forgotten to put the G here. That should be acting with gravity as well. So now with that corrected, it should be, the acceleration is 1.37. So this one has G as well because it's acting under gravity. And that's it. Well, meters per second squared.